Hello, everyone, and welcome to another episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we've got some of the big news around the faulty patches introduced in the Linux kernel, the Cellebrite hackback, and the return of 3DS exploitation, as well as some kernel fuzzing from Nedwell at P0. So we have quite a few interesting topics today. So we'll start off, as always, with some of the news. This one was big news. It circulated around on some channels where I wasn't expecting, though given the topic, it's no surprise, really. It's around the University of Minnesota students getting the university banned from authoring commits into the Linux kernel, and also getting their past commits reverted and flagged for re-review. The catalyst behind that drama was a paper titled "On the Feasibility of Stealthily Introducing Vulnerabilities in Open Source Software via Hypocrite Commits," which we have on screen. Z, I'll let you start first here, then I'll go into my thoughts on it.
Yeah, so there's kind of two things about this. So this paper that we're talking about, the Stealthily Introducing Vulnerabilities, that paper is from or at least I found out about it. I've actually been looking for it since, I want to say, about November of last year. The author of it published it initially and then took it back. It's been accepted to Oakland, so it will be officially published. At this point, it's still considered pre-pub. After Oakland 21, so that's next month. So this research already happened, but just this past month, there were some new commits made to the kernel. And that's kind of where a lot of the dramas happened. So the new commits, at least Greg asserts that these are known invalid patches, basically introducing vulnerabilities into the Linux kernel. Pretty much what you'd expect, given the title of the paper. The thing is, like I said, this research already happened, so I have some questions over whether or not this more recent incident was actually related to that. Because like I said, this research has already been done. The paper's been accepted. So this would have to be some sort of follow-up paper, and that's definitely possible. Like, they've decided to do extra research. It violates some of the things that we're told about the original research. With this original research, they submitted 3 patches. At no point did they become commits to the actual Linux kernel. All of the patches were kept just in the mail, or all of the vulnerable patches were left just within the mailing list. They'd submit to the mailing list for review, but they wouldn't submit, or they wouldn't try and commit that. And immediately, once a reviewer signed off on it, they'd be like, "Here's actually the good commits." They would make sure they were going forward with a secure commit and not trying to actually introduce this into the code base itself. This seems to have violated that. With whatever happened, this particular case, I should have had the link ready to go. They submit the patch, and apparently several of these patches made it through into stable. It just, I don't know, it raises questions to me because it is violating the things that we've been told about the research already, so it's possible that they're just lying. I don't like to say that the academic researchers are just straight up lying, especially when these statements came out well before there was any drama of it. So, no, Spectre, what do you think? Like, do you think it's just clear cut?
So I can offer a little bit of insight on the patches there. Basically, Greg was calling them out because they said, we've had known, bad patches from you before, mentioning that paper. What the patch author rebutted with was the fact that this wasn't actually from that study. This was from a new tool they'd written. It was like a static analyzer that had automatically generated these patches. I was just looking for the message really quick to bring that up.
The patch author actually made that claim that it was from a static analyzer well before there was any drama. That was before Greg actually came back with, saying they were doing this. Somebody else had asked, like, "Hey, did you find this, or was this like a tool that you wrote?" And he used that tool. So that story, at least, is consistent with what the patch author said about a month ago.
Yeah, so I think Greg's argument was basically like, you've been known to submit bad patches in the past. What was I supposed to think, seeing more obviously incorrect patches? And then going on to say, like, they don't appreciate being experimented on or tested with patches, either for, that study of the paper of trying to inject vulnerabilities, or for this like alleged static analyzer, without even pointing out that that's where the patch came from. Like they mentioned, you should have put found by tool. We are not sure if this is correct. Please advise. So
that,
it's a bit of a weird situation.
I don't know. They say that like you should have done that, and they probably should have. I'm not necessarily disagreeing with that. At the same time, like that's a pretty minor thing to then jump from, well, you didn't do that, therefore this is absolutely, more intentionally bad commits and this big problem. And in fairness, one thing that I will add on here is that the University of Minnesota has not contradicted this claim. And I feel like if it really were just static analysis tool that somebody wrote and they tried to come in, then all these problems happen. Had it been that, I feel like they would have been able to state that already and like kind of offered some proof on that in that regard. So the fact that they haven't offered any contradictory statement makes me think that Greg is probably correct here about what was going on. But there are still at least a few questions, at least to me, about whether or not, because this would be part of some further research at the very least. It's not part of that original research. It just, I don't know, it seems like the first research paper, like they took a number of good steps to ensure they're not creating too many problems. And then this one just seems to throw that away. Something just doesn't add up to me.
It seems to be a lack of oversight on the university side of things. So there has been almost like unanimous support for the Linux maintainers here, and support for the banning of the university, and support for the university seizing the study and doing their own internal investigation, because they were basically pressured into doing that. I will say, like, if this was a result of that experiment of trying to introduce bad patches, it is kind of dumb to do that on the Linux kernel, which is used on like millions of devices worldwide.
Well, the thing is, they took the steps so to make sure that the vulnerable patches weren't going to be introduced. Like I said, they didn't create any commits for them. As soon as somebody signed off on them, they would immediately provide a proper patch for it. So like they were taking the appropriate steps to ensure that they weren't going to introduce actual bad code. Because at least with the original research paper, they were. That's the paper that we've got up here. Like I said, that seems to have been violated by the second run, that we don't really know what's going on, that we don't necessarily know was part of the research. But at the very least, like I agree with they shouldn't be introducing bad commits. It's just, it goes against everything that they set up in the original paper, and that makes me think that something else was going on.
It almost seems like it could have been like a rogue researcher or something.
Then why use the Minnesota email, which is actually another thing. All of the commits during the research came from just anonymous Gmail accounts. They did not use their University of Minnesota emails, whereas these commits and the ones that are getting banned came from University of Minnesota.
Yeah, it's really strange. Like I said, there has been almost unanimous support for like Linux maintainers here. That said, I have seen a few arguments go against the grain a bit. One of them was what you were kind of talking and bringing up there, was the fact that we don't really have all the information, and it seems like there's people that are very quick to jump on and just go like, oh, bring out the pitchforks, basically. Whereas it doesn't seem as like cut and dry, I guess, as to what the situation actually like led to this problem. Another argument that I saw a few times was the argument that, okay, punish the researchers that were responsible for authoring bad commits, but you shouldn't be punishing the whole university. It seems like they're trying to, blanket punishment, I guess was the term that I saw thrown around.
Yeah, well, especially since the commits in the study didn't even come from University of Minnesota email addresses. Like banning University of Minnesota email addresses is a little bit excessive. I agree with not wanting to be experimented on. At the same time, I do think the research potentially had some value. I think this paper actually kind of falls a little bit flat in terms of that. basically they introduced 3 patches. They go in successfully, and like their recommendations on mitigations are like, well, you should update the code of conduct, because the code of conduct is definitely going to prevent anybody from doing these sorts of commits. Like, it's an interesting concept, because what they did was they did commits that would introduce the conditions that would allow for a vulnerability to happen. So in their code itself, none of them would be in the actual call trace of like a vulnerability happening or the use after free happening. It would just introduce the conditions that ultimately allowed it to happen.
Yeah, it was kind of like stealthily introducing them.
Yeah, well, that's right in the name there. And like, it's an interesting concept, and I think studying the patching or patch review process is a fair thing to look at. I think they could have gone about it better, like involving somebody from the senior maintainer or whatever, somebody on that side being involved, more like a penetration test where somebody on the other end knows about what's going on, is involved with it, and kind of step in and make sure things aren't going too crazy. Like, they definitely could have approached this a lot better than just going at it. I'm not going to have any disagreement there, but it's not that I think the research should just never happen.
Yeah, so I think overall, if I had to sum up like thoughts on this issue, I do think there were a lot of people that were a little bit too quick to jump the gun. I kind of fall on that side of people being too quick to persecute, and it's a little bit worrying, because like when we've been covering this issue, you can tell like it's a very weird set of circumstances. It's not as simple as people were like, the university was intentionally running a study to try to submit bad patches just because of that paper that was written. Like you said, it kind of could, the situation kind of conflicts with what they had set up in the paper. So it's kind of I feel like we don't have enough information in the like public perspective to be able to make a really solid case either way. So yeah, it did seem a little bit strange to me that like so many people were willing to go directly to the pitchfork angle, where the situation was just kind of hard to read into. That said, I do kind of respect why the maintainers would be upset about receiving these bad patches. Maintaining the Linux kernel is already extremely daunting, especially on the security side. They're already kind of stretched thin because companies don't want to pay for the security-based stuff for the kernel. This has been documented. They just want new active feature development. They don't really care about the security angle. So by adding the additional weight on the maintainers for trying to test like your static analyzer or whatever, I do kind of feel bad for the maintainers in that sense. But yeah, I mean, it just from the public perspective, it's hard to really give a really informed opinion because I just don't think we have the information necessary.
Yeah, that's the thing. Like, I think we're missing something. I don't know. Obviously, we can't really know what we're missing till we see it. But yeah, it's just the whole thing has felt very weird. Obviously, it's blown up quite a bit. Yeah, I mean, some of the patches though, like, are known as, or at least some of the maintainers have said, like, they're good patches. They actually fix something. So, like, there's the one here that kind of caused everything, which was what was believed to effectively be an impossible situation, and maybe it is. I mean, that seems to be the case, but yeah, I don't know. It's I feel for the maintainers not wanting to have their time wasted, but I also feel for, University of Minnesota here, especially until we know exactly, like, if they were actually introducing malicious commits, and like, absolutely, I'm not going to support that by any means. I don't want to come down as supporting that at all.
So it'll be interesting to see if anything publicly comes out from like the University of Minnesota's investigation. I think they did make like a public statement, but it was very vague and just kind of saying like, we're going to start investigating this, and we've seized the study related to the paper, and like, yeah, just not really much information there. I don't know if we'll get to see anything else. I could see them just kind of keeping that internalized, or maybe having some back and forth with Linux maintainers, but just in like the mailing list. And if, somebody doesn't pick up on that and share it around, I could see that easily just being lost to time. But yeah, I mean, if there are any updates to this, we'll try to cover them on the podcast, because it kind of sucks, but it's like, yeah, we don't have all the information, so it's hard to cover super well. That said, we can move into our next topic that also blew up this week, that was exploit related, and that was a post from Moxie at Signal, who basically did a hackback kind of at Cellebrite, which Cellebrite is an Israeli forensics or phone hacking company, right? So back in December, Cellebrite announced they had added support for collecting messages and data from Signal, which is kind of where the hackback comes from. The blog post goes into some detail about Cellebrite and what they do, noting two primary tools that they use, being UFED for backing up devices onto Windows, kind of like what iTunes does, but also with like Android devices and whatnot, and the physical analyzer, which takes those backups and parses them to display the data on in a browsable format. Incredibly, when Moxie went out for a walk, they saw a Cellebrite toolkit that had fallen off of a truck, which had all the various adapters and dongles needed for using these tools.
Yeah,
it was almost like a TV show.
This sounds like a very realistic situation, 100% truth.
So yeah, they decided to take advantage of that opportunity to look for vulnerabilities.
Yeah, and I guess just to kind of add on there, to be kind of what's going on with that is odds are Cellebrite terms of use, like whoever actually obtained this won't be allowed to do this sort of research on it. So by crafting the scenario where they are not agreeing to any of those terms of service, where they've just come across this, they've not agreed to those terms of service and thus can go ahead and do whatever they want with the device. They're not at fault, and they'd have to kind of figure out who was to do anything.
Yeah, it's kind of covering yourself, legally speaking. So yeah, they decided to look for vulnerabilities. They expected the software to be somewhat secure, given the nature of the company, but they found that the opposite was true. For one thing, which is like the main premise of the post, it bundled FFmpeg libraries that haven't been built or updated since 2012. Which means you wouldn't even have to look for like an ODay in their software. You could just try one of the hundreds of NDAs that have come out for FFmpeg since 2012. They vaguely go into some of the issues that could be utilized to it, or like some of the attack scenarios that could be used to attack Cellebrite. For example, planting a malicious file on devices that get scanned to modify all reports that are generated by Cellebrite, either from that were previously scanned and future scan devices. And there's like no integrity checking on those reports. They then also have this cheeky quote about we'd be willing to responsibly disclose the vulnerabilities we know about if they do the same for all the vulns they use in their physical extraction, which obviously isn't going to happen. I mean, that's their entire business model is breaking into and recovering data out of those phones. They also talk about some of the various other DLLs being used and how they likely don't have the rights to redistribute those in their software. Like I think there was various Apple DLLs, but that's by the by. That's kind of just tacked on at the end. That's not really relevant to the central idea of the blog post. But yeah, Z, I remember you were kind of mentioning around legal implications of the research being on kind of shaky ground.
Well, just because you'd have to agree to terms, and a lot of those terms are going to include, like, you can't reverse engineer, you can't look into it. It's pretty standard to see that. I will also say that Signal has also had their completely unrelated news that upcoming versions of Signal will periodically be fetching files to place within app storage that are never used, but and completely unrelated to the fact that those files could compromise Cellebrite. On the legal side, like, because Cellebrite is also going to be used for data collection, this calls into question pretty much everything that it collects if it can be compromised so easily. If you're able to get code execution on the device, you're able to write your own files and basically modify or change anything that it seems to report. I think for a while here, this is going to be something that I'm not a lawyer here, but it's going to be something any lawyer could go ahead and use and basically dismiss anything that it finds as potentially having been planted. At least until they determine some forensics or proof of it actually being compromised, some sort of indicators of that compromise.
Okay. So, yeah, I mean, I saw some interesting takes on the Signal stuff, like in the Twitterverse or whatever. I saw quite a bit of support for Moxie, saying, kind of go get him, I guess. There were also some people who were, especially on the Signal,
I mean, I definitely support
files.
that.
Yeah.
I mean, I see no problem with that. On one side, Cellebrite isn't exactly playing fair. Signal's going they're playing the same game. So I don't see a problem with that. They do mention that they expected the security software to have, better security. It's been my experience that security software quite often has some bad code. It's weird, but the more secure you'd kind of expect something to be, the worse it seems to be. Just from my experience doing the consulting and stuff, having dealt with some security products, I expect a lot better from so many companies, and they tend to be the worst offenders.
Yeah, you could coin a law for that. We'll call it Z's law, I guess, for now. But yeah,
I'm sure somebody's
observation.
Done that already.
Probably, but we'll just pretend like you did it first. But yeah, it's an interesting scenario. I did see some people kind of, I guess, questioning Signal with placing these files on the device. They do note that it's never used for anything inside Signal and never interact with Signal software data. But yeah, I did see some people that were kind of latched on at that point, were a bit worried. But yeah, I mean, I don't know if, I think people were kind of blowing that up out of proportion, just kind of taking that in isolation without any context. So,
I mean, I'm not even sure that Signal would actually be placing any files on there, or if they're just stating that they will.
Yeah, it could just be kind of like a cheeky throwaway line.
Even the statement that they will calls into question the results of Cellebrite, because it's the potential for it to have happened, and the fact they're aware of it. Doesn't matter if they actually do it, they're calling into question the results just by stating that they might.
Yeah. All right, so we'll move into our next exploit, which involves a privilege escalation on Ubuntu through OverlayFS. The issue has to do with permission checking when it comes to setting file capabilities and separating those permissions from namespaces. Essentially, it tries to ensure that whatever file you're attempting to set capabilities on, you have permission to modify that file in that file system. So if you create a user namespace, then mount a file system, you're able to set capabilities on those files, but not on a mount, say on the root user namespace that's privileged off. The problem here seems to be that OverlayFS bypasses the setxatra routine that would normally check for those permissions. It just skips to the underlying routine that gets called. It doesn't use the wrapper routine, which is VFS setxatra. So because of that, you could set arbitrary capabilities outside of the outer namespace, which they use to set capabilities on their own process. And they give themselves root capability, sysadmin, netadmin, everything essentially, which is why you get that root LPE aspect. So this
a fun vulnerability only impacts Ubuntu. Ubuntu is the only one where you're able to do this as just your standard user by default.
Yeah. So this affects Ubuntu 20.10 as well as all the recent LTS versions. Pretty impactful bug. There are some potential mitigating factors. If for whatever reason you couldn't patch and you don't use user namespaces for anything, disabling user namespaces is probably a good step to take just in general, since those are on by default and they can expose some pretty powerful attack surface. So yeah, I mean that's just a good idea in general to disable being able to use or create user namespaces on underprivileged users. But yeah, it basically just comes down to that check being too high up in the call stack. Which is interesting because there might have been other file systems that could have been used to get around this too, either currently or maybe in a future file system. So the way they fixed this was kind of smart, because what they did was they added the capability checking or the permission checking into VFS setxatra. So it's kind of future proof against like any future types of issues that could be found as well. So yeah, smart fix, and an interesting problem, and one that I don't think we see too often, but I think is pretty common. Just that idea of a developer writing code and then thinking, well, I don't need to use this wrapper. I'll just call the underlying code, and not realizing the implications of doing that. Yeah, it's just kind of easy to accidentally subvert security mechanisms. So, and that's essentially what happened here.
Yeah, and I mean, I commonly hit on the point of centralizing security and doing centralized checks. This is just kind of a example of that, where you don't want to force the developer to remember every location that they need to do something. Ideally, the more you can kind of automate away and just have automatically done, the better. At least for security.
Yeah. All right, so our next issue is in Synology Disk Station Manager, which is a modified Linux OS that's used for Synology NAS devices. So Z, I know you wanted to take this one, so I'll let you go ahead.
Yeah, there isn't too much to say here. I don't think we've talked about on the podcast AppArmor before. Actually, I think we did once or twice, so yes, we probably have, but I thought this was just kind of a funny issue. The synosearchagent has kind of a misconfiguration within its AppArmor profile. So if you're not familiar with AppArmor, the idea is you create this AppArmor profile, and then the app that kind of specifies like what the application can do, what it can access. It's kind of an easier to set up version of like SE Linux. AppArmor profiles are, at least, they're not painless to set up by any means, but they are a little bit easier, at least. So you'd have this profile. But anyway, what they found quite simply was that the profile allowed them to just load new kernel modules, kind of defeating anything, because you could just load anything and have kernel code execution. There's no more of a vulnerability. There's no trick to it. It was just a bad profile, but just kind of a stupid vulnerability.
That's a bizarrely large hole to have. Like if I was trying to set up policies to, sandbox untrusted users, I think the first thing I would think of was, let's not let them load arbitrary kernel modules. So
by default, it like blocks everything, and then so you could either write the policy manually or kind of look through the audit and kind of approve certain actions that then get added into the policy. So most likely somebody just kind of approved this very general sort of rule into it that end up allowing it.
Yeah, fair enough.
It's kind of bit by some of the setup options, I guess.
On what you mentioned earlier about AppArmor, I just did a quick note search. We haven't talked about AppArmor as far as I can tell. We have talked about Fruity Armor, but that is a very different thing. So yeah, just thought I'd throw that in there. But yeah, I mean, once you have kernel code execution, like you said, you can basically do whatever you want. There's no hypervisor or anything preventing you from taking full control of the system. So yeah, kernel gives you everything. We have the return of GitLab issues in this episode. For some reason, HackerOne is kind of failing to load for me. I don't know if... Okay, there we go. Refresh fixed it for me. But yeah, we have the return of GitLab issues and the return of Kramdown, which is used when rendering Markdown in wiki pages. Z, I'll let you take this one away as well, because I was a little bit late getting to this one.
Yeah, so this one... So we've talked... I believe we've had RC and Kramdown before. But this one... definitely different person. Also, I think it was DevCore last time, or somebody at DevCore that we talked about last time with Kramdown and GitLab. But Kramdown, it's like the Markdown parser. So GitLab, you might have a Markdown file, or GitHub. Sorry, this is okay. Sorry, it is GitLab. I got confused there because they talk about it calling the GitHub markup render. Looks like that they're using that gem. So anyway, it's GitLab. What Kramdown ends up allowing you to do is you can actually set options for the parser inline, so within your actual Markdown file. And they show the example of that just being like the : options, and then you can set whatever you want there. In particular, they use Rogue as their syntax highlighter. and that supports these syntax highlighter options. So what ends up happening is that you can specify the formatter, which ends up being loaded as a class. So you can specify what class it's going to try and use as a formatter. The class does have to match this, like starts with an uppercase character and then is alphanumeric and underscore characters only. Most classes are going to follow that, so that's not a huge deal. And you can effectively get any class instantiated there. And then you can also control the options that get passed into it. You'll notice here just takes another object there with various options that get loaded in. So what they ended up doing here for code execution is effectively they used the Redis class, gave it a driver, which can end up giving them, or you can tell what file basically to load, another Ruby file to load as a driver. Which they were able to just upload any old Ruby file. In its GitLab, you can upload files into whatever, and they can know where it is just based off of the general code. Not a huge deal. We've kind of talked a little bit about that before. But they were able to upload a file, use that as the driver for Redis, and get your Ruby code execution. I think it's an interesting attack surface. I didn't know you'd be able to set the options there, or that it would even go so far as instantiating the class based on that name, like without much checking. So that kind of seems like a very questionable way to go about it. At the same time, if you're trying to support, other people to develop their own formatters, you don't have a lot of choices there. Like, you've just got to support whatever. So I thought it was an interesting attack to go, or interesting way to go about it. Fairly straightforward on the whole.
So I thought it was kind of funny when you got like the GitLab and GitHub mixed up, because last time we covered Kramdown, which was on episode 50, by the way, we actually covered it in GitHub pages. Was where the issue happened last time. So because the topic name was GitHub pages multiple RCEs via insecure Kramdown configuration. So yeah, it's kind of used in both GitHub and GitLab. So it's that was kind of a funny point that I thought I'd bring up. But yeah, I mean, this seems like a pretty interesting attack. So I did kind of wonder one thing with the asset. It says the asset that would get hit is your own GitLab instance. So this wouldn't affect like GitLab.com, like the managed instances. Or I just want to verify that, because like the bounty payout they paid out was pretty big. It was $20,000. But I just want to make sure like it was only on the like self-hosted GitLab instances.
I didn't look into that actually, so I can't comment on whether or not it is only that. I assumed this was hitting all of them. Like, I assumed this was just hitting GitLab in general. That's that file upload thing that I mentioned. Especially since you're mentioning that we last time we covered this, it was on GitHub, so I might be thinking of some that was particular with that on the file upload system. So that might be, well...
Yeah, like I guess the reason I ask is because when I was looking at this issue, it seemed very general. It didn't seem like something that was specific to the self-hosted instances, so...
yeah, it doesn't appear to be. To me, like, reading this, it sounds like something that could hit pretty much any of them. But, yeah, I really don't know.
Okay,
because you're raising the question, like...
Yeah, it was just something I kind of noticed in the meta details of the Hackerone report. I will quickly cite from chat. Rudy Mel says, are researchers allowed to test for some main instances? That is a fair point to bring up. It's possible that this affects GitLab.com as well. They just, like, the researcher didn't know that because I don't think they're allowed to test directly on GitLab.com, are they? That would seem kind of weird to allow on their part. I'll just quickly check the...
Well, yeah, I've pulled up the Hackerone page to see. Yeah, testing on GitLab.com. Your wearehackerone.com address must be associated with the testing account. So you can do some. You can do some testing right on the GitLab.com.
Okay, interesting. Yeah, I'm just reading that now too. All right, so yeah, I'm not sure. But basically, like, it's possible that this could hit GitLab.com, but I'm not totally sure. They don't really clarify that in the report, unfortunately. So
Yeah, they do have
just kind of speculation, but
they do have rules regarding like your testing. You have to take care when testing things that might compromise the privacy of other accounts. So code execution would be one of those cases where you kind of have to take care. So I imagine a lot of people will just test on like the self-hosted version because that is a bit more straightforward to do.
better to be safe than sorry, basically. So yeah. But yeah, this seems like an attack that could potentially hit GitLab.com because, like I said, that these issues specifically, like it doesn't seem to be exclusive to self-host. Anyway, we'll continue issues that involve Git. We have an issue that affects Homebrew, which is a popular package manager on Mac OS. Very useful. I've used it quite a few times myself. Specifically, it's in the continuous integration pipeline on GitHub through GitHub Actions. One of the workflows they have set up is this review workflow, which tries to fetch pull request changes in the form of the diff file, and it parses it to perform various checks to see if pull requests can be approved, such as checking if like the number of additions and deletions match, if it's only modifying one file, and it also does some other pattern matching on the metadata. And to do that, it uses git diff, which is a Ruby library for parsing diff files. The issue here is ultimately in git diff and how it parses for file changes. So what it tries to do is it parses out the destination file path by checking for the triple plus b/file pattern for the destination file. The problem is a malicious pull request can force that pattern to occur by injecting content into a file that, when put into the diff format, would match that pattern. So that can allow them to change the destination file path on an evaluated diff and get the pull request accepted when it shouldn't have been. So you could write like arbitrary Ruby into a Ruby file, such as the Homebrew Casks, and get it executed upon installation by abusing this vulnerability. This seems like kind of a unique bug. Ultimately, like I said, it's not really Homebrew's fault. It's a bug in the dependency, but Homebrew did take some steps to remedy it. Essentially, they just remove the workflow entirely and remove the auto merge GitHub action. But yeah, I mean, this was ultimately an issue in the library, which still hasn't been fixed. I did check the repo. An issue has been opened by the researcher, but there's been no activity on the issue. So yeah, who knows when that'll be fixed. I did take a look at the repo, and it seems like changes are only made like every couple months or so. So yeah, it might be a while before that's fixed as a dependency. So if there's other projects out there that are using that dependency and using it in a similar manner, then those could potentially be vulnerable as well.
Yeah, and I mean, one of the main things that they could be checking here is just if they've already set the destination path. Like that +++ should only happen once per diff output, like per file that's actually going through. It should only see that +++ once. So yeah, I mean, it seems like there should be a fairly easy fix. I always hate saying that because yeah, there's always more than what I'm able to see. But yeah, it's a fun attack nonetheless, like to take advantage of the fact that new line additions also start with that plus. So by having a new line that starts with 2 pluses, you get the triple plus and you're able to basically have it ignore the line thinking it's metadata and change the file that you're writing to make it think that you're writing to some that it supports, getting you kind of that 0 changes to a safe file. So it'll think it's okay. Like I said, it's a very unique situation to have something that's going to parse through like this. Like I could imagine other places maybe do something similar, but it's very much like, in particular, how they do it here, it has very damaging implications.
So one thing I found very interesting when I was reading through the report was they asked the researcher to do a POC by doing a harmless compromise on an existing cask. I believe they targeted iTerm. This is essentially like POCing a bug in production, which I thought was kind of strange. And I thought it was extending perhaps a little bit too much trust to the researcher. Not that the researcher in this case wasn't a good faith actor. In this case, it was fine. The researcher didn't do anything harmful. It just did like a print or whatever. But I'm not sure I like the idea of getting a researcher to test like that. They were basically like, yeah, we don't want to create a cask just for testing this issue, so just hit one that already exists. Nonetheless, like, the issue was remedied on Homebrew's side, but yeah, I don't necessarily agree with the way they had him POC the issue, because if it was a bad faith actor, they could have done some damage with that. Like, it was basically the way an attacker would have taken advantage of it, just not using a malicious payload.
But a bad faith actor could have taken advantage of it without having gone through them in the first place.
Yeah, I mean, that's true, but it's just the way that they asked him to test it just seems so strange to me.
I mean, there's a lot of risk if something goes wrong with the testing. Like in this case, it seems fairly straightforward, but there's kind of the risk that they accidentally do something that does create more damage unexpectedly. So that's where using a test cask would have made more sense. But I mean, if they were trying to be malicious, I don't think the fact that they wanted to reuse a cask really would have been where it came from.
Yeah, okay. Yeah, I mean, like you said, it's if they really wanted to do damage with this, they would have done it already, and they wouldn't have submitted the Hackerone report. But yeah, it's just that's the first time I think I've seen that kind of process of testing in production happen on Hackerone. Etienne just said in chat, I've been asked to test things in prod before as well. So, okay, fair enough. I guess that's just something that I haven't really seen too much of. But yeah, if it's a fairly common thing, that's totally fair. It's just something that kind of jumped out at me. But
it's a bad practice, but it's a practice.
Yeah, it's something that kind of exists, and you just have to accept it, I guess. So yeah, like I said, in summary, the issue is still in the dependency library, so who knows when exactly that'll be fixed, but Homebrew did take steps to mitigate it on their side. All right, so we have the first of two Talos blog posts up next. This one covering two RCEs discovered in Cosori? I think it's Cosori. I don't know. It's one of those terms that I just kind of have to guess on how it's pronounced. Cosori smart air fryers, which uses Wi-Fi to allow users to remotely start and stop cooking, look up recipes, monitor cooking status, stuff like that. Since this is IoT, you don't need to expect too much out of these issues when it comes to complexity. Both issues come down to
potential damage could be, maybe. So I don't know if they tested this, but starting a fire with your device, some very real world potential.
I would hope they would have some kind of defenses from being able to send packets that do something that malicious in order to start
given
a fire,
that you're able to control some of the the heating temperatures and stuff. I mean, I'm sure they have limits in place. Although
I would hope
you control the entire device, so can you get around those if you wanted to?
I would hope they have some hardware protection, but.
Well, on the other hand, you're also potentially starting this at an unexpected time. Maybe somebody has something flat, like piece of paper sitting on top of it or something. It would be hard. An attacker wouldn't know that. But, there are some potential side effects here.
Yeah. So both issues are from the vector of being able to send packets over TCP, which the packets are encrypted JSON. While it's good that they're using crypto, they're also using symmetric crypto with a static key and ID that's embedded in the firmware. So it's kind of flimsy. The crypto is there, but anyone who can get access to that firmware can just dump it and reuse that key. It's kind of flimsy, and it's something we've seen before in IoT. I think we've covered this exact issue in smart locks. They had static keys that were in there that anybody who could pull those keys could just use on any other smart lock. Getting to the issues though, one of them was just allowing you to enable developer mode through config packets, which you can use to update the firmware without any authentication. It's basically an unauthenticated backdoor. The other one was heap overflow and parsing config packets due to no bounds checking being present when printing a URI to the console when receiving invalid requests. It only allocates 104 bytes for that data. So by sending more or using a really large URI string, you can overflow into the heap and get code execution. Again, with these IoT devices, you're the mitigation game is basically non-existent. So yeah, I mean, there's not really going to be
Yeah,
any hardening.
they don't really talk about the mitigations, I don't think. They just kind of get to the crash. And that's a lot of the Talos reports. Get to the crash as their proof of concept and kind of leave it at that. This one's no different. That said, there was one thing that I didn't entirely understand. It's kind of a minor point, but this thing has a buffer of 104 bytes. But they talk about to overflow, you only need to send an additional 60 bytes. But the URL, and they're saying like, and some of what you send will be overwriting like EIP at that point. Or not EIP, it'll be overflowing into the next thing. Overflow occurs. Execution pointer is restored to the last 4 bytes of what you send, yeah. But 60 bytes just seems really small, considering it's 104 byte allocation. It looks like this is around the start of what gets printed out. So I wasn't sure if maybe they meant to say 0x60, because it's 0x68 bytes in total. I don't know if you noticed that.
No, I hadn't. I'm just reading it a little bit to try to... Yeah, I'm not sure. I was just looking at the fatal exception, and I could see like they modified the program counter to go to like DDDD or whatever. So yeah, I'm guessing they just threw like a payload, like a cyclic pattern in there, and they were just like, oh, here's where it happened. And it's possible they had a typo there and they meant hex 60, but I'm not certain there.
Yeah, well, I'm not certain either, and it's also the fact it's a heap overflow, and then they talk about getting the execution pointer. Which usually if it's calling a function or something on what you overflowed. So I think now that I'm thinking about, maybe there is just a step where it's dereferencing something in that next buffer that you overflow into. And that's kind of where it happens. Probably something like that. Yeah, I don't know. It threw me off a little bit seeing just 60 bytes when we're talking about a much larger buffer.
Yeah, that is one thing that kind of sucks with the Talos reports, is that you're always kind of left wanting to know a little bit more. They just kind of talk about the issue quickly and show the crash, and they're like, okay, we're heading out. There's nothing on the exploitability angle, which is fair, like if they don't want to cover that, but it's just, I really wish they covered that more, but they don't, so it's pretty much pure speculation on that. But yeah, I mean, the issues themselves are pretty straightforward. There's nothing super complicated about them. Again, this is another one of those issues where the bugs would still exist, but it might not be exploitable if they had some strong defense in depth with the crypto they were using and used like asymmetric encryption. I get why it's difficult to do with like IoT, but I feel like it's one of those steps that should probably be taken. Just because, like, if the packets are encrypted, then the tampering is already made more difficult, right? You would have to compromise a device which already has those keys or something like that. You couldn't just use like any arbitrary device and just copy the key over. You could at least make attacking the issues harder, but yeah, I mean, in IoT, it just seems like there's no incentive or drive to try to do stronger crypto. So, whatever. Kind of a moot point, I guess. It's just how IoT is.
Yeah, I mean, even just like the firmware update, even just having it signed.
Yeah.
Something like that could go quite a ways.
Also, I just caught myself, and I'm going to correct. Earlier I said this is the first of 2 Talos blog posts. This is actually the second of 3, I guess, because the Synology issue is also Talos. So
yeah, this one, I mean, they have one main report and then the 2 sub-reports for it.
Yeah. So next we have a follow-up with some technical details on the source engine vulnerability, which we talked about a little bit before when we were talking about Valve and their ridiculous bounty situation on Hackerone. This issue was at least finally patched by Valve after 2 years, and so Flosen was able to post a write-up about the problem. It's the RCE that can hit victims through Steam invites on CSGO. For those who haven't played CSGO, one of the most popular features is the ability to host and join community servers. Now, that's an action that a lot of players probably take lightly, thinking, oh, whatever, it's just a game server. I'm just going to go on the surf server or whatever. But those game servers can actually do a lot. They send files that get parsed by the client. And there's communication facilitated between the client and the server through the Archon protocol and source engine. One of the things that the function facilitates, one of the things that the function that facilitates Steam invites has is the ability to support the PCH connection string parameter, which can allow commands to be specified upon accepting an invite to join a user. And at least until this issue was addressed, there was no indication to the user that this string was being used or that there were commands being ran on their behalf. It just kind of happened in the background. So what you can do is you can specify an Archon command that gets ran on behalf of the user, which in itself could be useful for other attacks, like leaking their IP address or whatever.
Yeah, and I guess I'll clarify a little bit. Archon is used where it's like the server admin would be using those things within their own kind of game console. The connection string you mentioned is added as an argument when it goes to launch the program. So you would use that to then say and run this game console command that's going to join them to whatever lobby ID. That's the intended use case here for just being able to add anything there. But the Archon itself is kind of authenticated, but if you're controlling it, you tell the victim, go ahead and just connect to this server. You give it the IP that's going to connect back to and try and authenticate to, accept any sort of authentication or don't ask for it. I'm not sure if they really cover how they dealt with the authentication, but presumably you control the server. So, there's no, it shouldn't be a big deal to just accept whatever. So that's where they can then make these other requests or get responses, such as what you're just talking about with the files that can come in. In particular, they found an issue in parsing the screenshot response, which I'll let you carry on with.
Yeah, so one of the things you can do over Archon is take screenshots, which are then sent back to the client in zipped form. Since this file is controlled by the server, which would be attacker controlled in this case, it's a viable attack surface for attacking the client. They found a stack overflow in the xzip and xunzip libraries, which the game or Archon or whatever uses for handling zip files. The overflow happens due to how they parse the relative file offset of the local file header from the central directory file header, which then gets used later on when it tries to process that local file header. If that offset is really large, like hex 7 Fs and then E, there's an underflow that can happen when it tries to calculate the position in the file stream for the header data, because if the stream position added to the offset to read is greater than the stream length, it sets the read position to the stream length minus the stream position. Well, if you have that really large value, that becomes the max unsigned val for a 32-bit integer, which when subtracted from the stream position leads to an underflow and the ability to smash the stack. Because of the circumstances of the bug, the exploit was pretty straightforward. They literally just smashed the stack with ROP gadgets. They didn't even need a direct info leak to chain with because one of the modules, xinput I believe, didn't have ASLR enabled. So as long as that module was loaded at the preferred address, they were basically golden for exploitation. It wasn't 100% reliable, but it works. They say it's around 80% in terms of reliability. And they actually eliminated that as an issue by making it so they could have a persistent exploit by binding that Archon command to a key that frequently gets hit by the player in their config. So if they fail, unless the user changes their config or notices the bind or whatever, you can just try it again. So the key that they used was the tab key, which is like the default key for opening up the scoreboard. So if somebody joined a game or whatever and then opened up the scoreboard, they would immediately get popped with the exploit, which I thought was kind of a fun aspect to it as well. Yeah, in terms of timeline, as you likely already know, it's abysmal because it's Valve. The issue was reported in June of 2019. The bounty was paid, and an initial fix was deployed in TF2, I believe, in October of 2020. Then it was finally fixed in CSGO in March 17th this year. So, yeah, it's taken almost 2 years to reach resolution in CSGO.
I mean, it took more than a year from the bug being triaged to a bounty being paid. That's a little bit excessive.
Yeah, I mean, it's Valve. Yeah, I mean, I kind of already ranted about this, but they should just not have a program on HackerOne unless they plan to improve that, because if you're going to leave issues sitting in limbo for a year or 2 years, you're just screwing everybody at that point. You're screwing over the researchers who want to share their work, who potentially want a bounty payout as well. You're also screwing over your customers because you're leaving these holes in place and not bothering to fix them. And in a lot of these cases, like especially Source Engine, it's kind of a meme target. You're gonna find so many stupid issues in Source that are uh, like 90s era exploitation, like these buffer overflows. They're not super complex bugs. Oftentimes, from what I've seen in these patches, it's literally like a one-line change in the source code, and it's very straightforward, like adding a bounds check. And it's kind of outrageous that it takes 2 years for a one line of code change to land. It's just not really excusable. At least in this case, though, it was eventually fixed, but it's like that's a very low bar.
Yeah, it took quite a while to get fixed. It seems like Valve has kind of made some statements that part of this is just due to the large number of code bases and teams involved with fixing some of these reports. Which I can, to some extent, I can understand them saying that, because it's like, okay, it's in this game and that game, like, you know, there's plenty of different areas some of these could creep up in, but I would assume that there's still some sort of like central library that they're sharing, but I might be mistaken on that. They might just kind of fork the library off, and then, you know, all these teams have to kind of work together to deploy a fix around the same time. So it sounds like some bad just engineering policies. Feature creep, something like that, perhaps.
I'll say I think that excuse is entirely BS, because the way that Valve works, and this has been publicly stated, is like basically at Valve you work on whatever the hell you want to work on. There's like no, like you can just move between teams.
Who wants to work on bug fixes?
Exactly. That's the problem. It's like there's no cred, or there's no like incentive for people to fix bugs internally at Valve. They have people working on like skins and working on cases, and that's pretty much all CSGO development is now. So I think the issue isn't that there's like a complex mismanagement between teams or whatever. I think it's literally just that nobody wants to bother at Valve, and they just don't care. And it's sad, but that's the reality. I think that excuse with like the coordination between teams is just something to try to make them sound a little bit better. The issue is just that nobody wants to do it.
2 years is excessively long. Like, even places like very large software companies, you know, your big end companies, can respond quicker. Obviously they have more mature security process, but no, I mean, 2 years and especially I think when we were first kind of talking about there being an RC, I had some questions over maybe there was a more valid reason for Valve to have not fixed it, but this is kind of clear. It's a clear vulnerability. Like, there's no real excuse on it.
And it's unfortunate because I've been noted in the past on this show actually saying like, Source Engine is kind of an easy target, but if you're looking to break into exploitation and you don't want to do like super complex stuff and you just want a fun target in general, Source Engine is probably an area to look for you. And like Valve pays pretty well on their Hackerone page, but like back then, I guess I wasn't really aware of just how bad their program was. Like if I was covering those topics today, there's no way in hell I'd be recommending anybody to take part in Valve's Hackerone program. As much as Source Engine is a cool target, like if you want to look at it just for the sake of looking at it and trying to do exploits, then fine. But in terms of expecting like a payout and trying to go through the program, just don't bother. Like your program, your bounty's going to be sitting there for years. It's just going to depress you, honestly. It's probably just going to sap all your motivation, knowing that you put all this work into getting a full chain exploit and just not getting any like recognition or payout for it. It's a waste of everybody's time. Now that said, like they do have some final thoughts on the situation with calling out Valve in the Secret Club post, saying that they didn't just want to point the finger at Valve, but saying that they wanted to try to affect change with how Valve runs their bounty, which I thought I'd shout out since it's there. But I mean, Valve totally deserves to be called out here. I don't think they should feel bad about making that initial statement. I hope that the direction does change on how Valve is running the program, but I really don't hold out any hope. if the past like 10 years has taught us anything with Valve, it's don't expect anything because they don't care. They're going to continue making money. A lot of the like players in these games aren't even aware of these issues or don't even care. So it's like Valve doesn't care either.
Yeah,
Whatever. I don't expect it to change, basically.
This is one of those places again where I feel like HackerOne could affect change, could kind of lead any of their anybody that's using their platform towards having a more mature process and actually work towards improving it rather than just facilitating a program at all. I mean, it's great that they're doing that, and I've gone on my soapbox about this a couple of times, so I won't do it again, but this is just another example of where, HackerOne is in a great position to make positive changes for security, and they just don't.
I mean, I don't know if this is a hot take, but I feel like if you're running a program on HackerOne and you have a consistent track record of leaving issues unresolved for like years on end, you should be banned. Because what's the point?
So I've seen that comment.
You're
not the only person that's stated that. I disagree.
You disagree?
Okay. I think they should. I don't want to say no. These companies just shouldn't get to have any programs at all. First of all, bounties, like there are HackerOne programs that don't even do bounties, so we can ignore that aspect. I want to encourage companies to have vulnerability reporting programs, and HackerOne makes that easy for them. I'm not going to suggest that we start banning people from having that, making this sort of testing either Valve has to maintain it all privately, or it just becomes illegal to do this testing. For some definitions of illegal, won't go into the legal aspect there. At least with this, there's a route for researchers. It's not great. That's why I think HackerOne should be pushing companies to improve, but I'm not going to support banning people from having a HackerOne or banning programs from being on there just because they take a while to go through with it. I think, if they included triage time as one of the metrics on like a HackerOne page, that might help researchers maybe decide they're not going to look at HackerOne because the triage time or the payout time is so long. I think they could include that information to kind of assist researchers in knowing, but I think banning's the wrong route. I mean, if we want these sorts of vulnerability disclosure programs to exist, and banning them for taking too long is not friendly to the companies at all for that.
So let me elaborate a little bit on why I kind of would want like Valve to be banned, for example, is whether they're intentionally doing it or not. What this practice essentially does is suppressing research, because you're kind of leading researchers on a string, saying if you don't talk about it, we'll pay you out. It might be 5 years down the line, but hey, we'll pay you out. But don't talk about it, because then you'll be banned from our program, right? That's public disclosure, and we want to be able to fix it first. It's like it's almost actively hurting the research side of things, because nobody's ever able to talk about their research or the issues they found. It's like, I want to say like buying silence, but it's not even like they're buying it, because they're not paying out for like over a year. It's like they're just using promises and whatnot to silence researchers, and that's why I think it's actively harmful. That's why I would kind of want to go that route of banning them off the platform.
But as a researcher, if you wanted to give up that payout, you could go ahead and start talking about it. Like I said, they're buying that silence. They're paying a price that's acceptable to the researcher.
Yeah, I guess. I don't know. Like, I feel like having a bounty program like that where you're wasting everyone's time is worse than just not having a bounty at all. But I guess that can come down to...
I mean, there are bounty programs that don't like you disclose at all, too. I mean, plenty of the HackerOne activity is, non-disclosed reports.
Well, my problem isn't specifically that they're not allowed to ever talk about it. It's that they're not allowed to ever talk about it, and it's not like it ever even gets fixed anyway. So it's like it's the worst of every world, basically. So yeah, I mean, I guess it comes down to a difference of opinion on whether you think the running the bounty like that is actively harmful. In my opinion, it is. I guess in yours, it's not. But
Well, no, you make a fair point about the harm that it does. Like, I don't actually disagree with you on the fact that there is some harm being caused by them delaying disclosure for so long, and by kind of, as you said, just drying it out. Like, that is a very good point. I'm just not sure banning a program is the right route to go. At the same time, I was saying, like, I think Hackerone should be pushing companies towards having a more mature process and all of that. Banning could be part of that. So I guess I'm not entirely opposed to banning programs. I don't know. I mean, that's kind of why I'd rather maybe push things towards being less promoted, less seen, or making researchers aware of these issues up front so they can decide whether or not they want to spend the time on it rather than just getting rid of it. Because I do want to see more of these, more programs to just report the vulnerabilities. And I don't know, banning the bad one just feels like it's going to be in the wrong direction. But I guess, but your point's valid. I don't have a good response to that, and I don't entirely disagree. I don't know what the solution is. I just don't like the ban idea.
So banning might be going a little too far, but yeah, I think we can both agree that there should be some kind of steps taken to, whether it's negative consequences or positive, incentives to get companies to try to like remedy their situation there, so that companies like Valve aren't just getting away with this kind of crap with the way they're running their bounty program. I will quickly pull from chat. It's the N asked, would HackerOne ban you if you broke disclosure? From what I've heard, generally you're only banned from that program. I don't think they ban you site-wide. That said, I could be wrong. There could be some cases where people have been banned site-wide. But like that's kind of anecdotal, right? I don't really do stuff on HackerOne, and I've never tried to like break a disclosure policy to see what would happen. But from the cases that I've heard from like people that I've talked to, generally they're only banned from that program, which I think is the better step to take. I don't know if I would necessarily want people to be banned site-wide for violating one program, because in cases like this with Valve, I think you could be justified in some instances for breaking away from it. Or if like the company is like, we don't think this is an issue, we're going to close this don't fix. And then you decide, okay, well then if it's not an issue, then I should be able to talk about it, right? Which I support. So yeah, I mean, there's a few different like angles to it, but yeah, I think everyone can agree here that Valve is just kind of needs to be able to change something, which I don't hold out a ton of hope for. But the actual issue is pretty cool, I think. And the lack of needing an info leak was a really neat angle, because that is one thing with Source Engine. You can find memory corruption bugs fairly easily in Source Engine just by doing like basic fuzzing on like certain subsystems. The part that makes it really difficult to get a full chain is that you often need an info leak. And that is a lot harder when you're talking about Source Engine, especially remotely, because just given the nature of how you're compromising things, like map files is a common one, popping a client through map files, info leaking through that is really tough. You don't really have a lot of options. So yeah, being able to skip around needing an info leak is what makes this issue that much more impactful, right? For one thing, it's one less thing in the chain that could potentially, you know what? I was going to say that could potentially get burned, but it's Valve. It's not getting patched anyway. Or it wouldn't have gotten patched anyway. But just requiring one bug is something you don't always see with Source Engine and targets like it. So it was cool to see that. Anyway, we can move on to our next game hacking topic, which is the 3DS.
Yet another HackerOne.
Yep, another Hackerone report. This was a heap overflow when decompressing received levels on Super Mario Maker through Street Pass, which is that feature where like the 3DS can communicate with nearby systems, so that you can, play with somebody in your house or whatever. But yeah, I know Z, you're into Mario stuff, so you must have found this one kind of cool.
Yeah, I thought it was kind of cool. I actually thought the exploit was kind of cool. The fact that it's Mario Maker is just a nice Touch, I guess, since I'm at least a fan, although I don't have a 3DS, haven't played the 3DS one. Nonetheless, I mean, the vulnerability here is when it receives a compressed level, as you would expect it to be compressed. So it'll receive that. It'll be a maximum receive size of 0x 18,000 bytes. But it doesn't actually parse the size. So what ends up happening is as it goes to decompress, it looks at the chunk, sees like a chunk header, and decompresses. It just has this buffer 18,000, has another buffer that it can write into. So as it decompresses, sees the header, sees whatever, copies that into that decompression buffer, and then since that buffer is immediately following the other one, as it's looking for the next chunk, it's just going to look at that header, which is the decompressed data, and just going to be like, hey, is this compressed? Yes. Okay, let's keep decompressing and move it on. It's just kind of an interesting. So obviously with that, because if you basically have it like compressed inside of the compressed file, so 2 layers of compression, then that second layer will end up being written like 18,000 bytes. So off the end of the actual destination buffer, it'll basically just keep going until it can't decompress it anymore. Just because it doesn't actually check that size. So I thought that was just an interesting attack to kind of layer the compression in that way to get it to decompress. It kind of depends on the fact that those 2 buffers are right next to each other, that decompresses into the exact next space of memory from the original buffer. They don't really talk about how you could gain code execution, just it's a 18,000 byte, well, up to 18,000 byte overwrite on the heap. You've got a lot of control. Actually, as we were just talking about with the last one, ASLR might be an issue here. I don't know what the mitigations are on the 3DS. Do you know anything about that, Spectre? I know you've been at least more in touch with the console stuff, but I don't think 3DS is really up your alley.
So I have looked a little bit into the 3DS security. I mean, I haven't gone digging into 3DS code or anything, but I remember seeing the CCC talk given about 3DS security. I don't know specifics on which mitigations are in place, but I believe it's pretty strong as far as
well, so current exploit out of chat just mentions that there's no ASLR on 3DS. So that does make things easier. If there's no ASLR,
okay, that's weird because I was under the impression that it did have basic mitigations. But actually, yeah, I'm looking up and some other write-ups are mentioning the fact that no, there's no ASLR. So, because this one was talking about save game vulnerabilities, which is another area that's interesting for consoles, but it's often dead because ASLR pretty much kills all those issues. So, yeah.
It sounds like you might be able to exploit this one. Report doesn't go into it. Report gets the crash. It's a fairly big overwrite. You control the data that's being written because you control what's being decompressed. So I would imagine you're probably able to get an overwrite here. I don't know on how you would necessarily... The type of grooming that you'd be able to do to control the heap might be a little bit challenging. Like if you're trying to get a victim here. I don't know, like this also isn't really the type of thing you're... Like, what are you going to do? Compromise that 10-year-old walking down the street? Like, I don't know how likely this is to really be attacked, but...
Well, it would mostly be like a self-attack, but you probably need like 2 devices to be able to do it, so it's even not ideal for that.
Yeah, fair. I wasn't really thinking of, like, doing it for Homebrew.
Yeah, I mean, well, you could do it for Homebrew, but there's better options because this one's just not super ideal for either case for hitting somebody else or hitting yourself.
Yeah, regardless, like I think the vulnerability is still kind of cool. Like I said, just decompressing and then it'll try and decompress the decompressed data just by luck, but I think that's still kind of fun.
So, like you said, not too many details. It's a limited disclosure, which it's Nintendo, so that was kind of to be expected. Researcher did get a bounty of a very specific amount. It's $2,738, down to the last dollar, which is kind of interesting, but I just thought that was funny. But overall, I think the issue is cool, and it's always fun to talk about console stuff, and especially portable consoles. Like 3DS and Switch have always been really interesting targets to me, just because Homebrew is a lot more attractive on those platforms, whereas unfortunately on something like the PS4, it really is just a glorified worse performing PC. So Homebrew is not really that fun on like PS4, but on 3DS and stuff, it's really interesting, and like Vita, for example, too. So,
or as Blake mentions, PSP, original PSP. I did a lot of homebrew on that.
Did you? I didn't know that, actually.
Yeah, well, that was back in my teens, so good times.
Cool. So we'll get into our last Talos issue, which was a report on an out-of-bounds write in a 3D printer slicing program called PrusaSlicer. The vulnerability is in the .object file format parsing, particularly when it comes to parsing objects with an invalid number of vertices, because an object file is essentially a flat file which describes vertices that define the shape of an object.
So it's not quite an invalid number. And I have a theory about why this code kind of happened. But so the thing is, officially they support code that, with these objects, they'll have either 3 vertices, so a triangle, or 4, like a square rectangle type thing. Their code is written assuming 4. Like it seems like the code here in the vulnerable code just assumes it's 4, and if it's a triangle, the last entry will just have a -1. But they actually do a check for like invalid vertice count. I think it's towards the end they talk about checks for face vertices is not equal to 3 or not equal to 4, it gets rejected. So in theory, they're supposed to support these ones with 3, but the actual vulnerability seems like they just end up assuming everything's got 4. And did actually take this into account. Like, had they not included the not equals to 3 check at the end, this wouldn't have been vulnerable. But sorry, you can go ahead with actually explaining the vulnerability.
Yeah, so I mean, that was good to clarify, because this issue was a little bit tricky to follow for me because of that aspect. But yeah, like PrusaSlicer and most things only truly support polygons or triangles and squares, which are essentially like 2 triangles. And these sets of vertices are passed in a facet, which contains 4 vertices slots. So when it parses these vertices, it expects them to be in groups of 4. Like you said, it kind of takes that angle of setting -1 to the vertices that aren't actually used. So what happens, I believe, if you have a total number of vertices that isn't a multiple of 4, is like it'll check the modulus of the number of vertices by 4 against 1 and 2, but it doesn't check 3 properly. So if you pass an odd number of vertices, you can end up with this out-of-bounds read situation. And I believe the reason for that is if you have a vector of multiple of 3 elements, the code in load obj will unconditionally loop through the next 3 vertices. So when it comes to looking for that last vertex, I believe that's where the out-of-bounds read comes into play. It was a little bit confusing.
Yeah, no, that's how I understood it too. It assumes there are always the 4 vertices there. So then the fact that you have the one that isn't, because like the code in theory accepts that, but like I said, it accepts the 3, but then the code's actually written as though it only has the 4. So yeah, it does that 3, gets you an out-of-bounds by 1, or off by 1 issue.
Yeah. That can then lead to an out-of-bounds write later on when it goes to grab the next facet and operate on it. This seems like it would be a tricky bug to exploit. They don't really talk about the exploitability. Like we said, Talos doesn't really touch on that stuff. So it's hard to say how exploitable this would be without knowing a lot about the target. Why I think it would be tough is because heap spraying would be very difficult in this situation because it's a parser bug. So yeah, I mean, I don't know exactly if you would be able to exploit this. Maybe you could, but it's hard to say without knowing the target.
You need to spend more time on it. Just leave it as don't know.
The code itself is very let's just say sloppy, because when I was trying to understand the issue and reading the code, they do a lot of stuff in this for loop, and they increment the iterator a lot in like different places. That is essentially the basis for how this vulnerability happened, is because you have these different areas that can increment different like iterators and or counters that then get assigned to the there's so
It's
much
always
operations
worrying.
happening here.
Always worrying when something messes with its own iterator from within the loop. Like, it definitely happens. There's fair reason to do it, but it's one of those areas that ends up getting messed up a lot too.
It's a massive code smell when you see that. So yeah, I mean, code doesn't look particularly strong, so it's not too surprising there was a vulnerability found that involved it. But yeah, cool issue. Like I said, though, hard to know how exploitable it is. If I had to, take a guess, I would guess that this probably isn't really exploitable. But yeah, like Z said, hard to say for certain. All right, so we have an Adobe Acrobat Reader UAF write-up from Exodus. The CVE is a little old. It's from 2020, and ZDI did a post on it last September. But this delves deeper into the exploitation angle. So the UAF is in the JavaScript engine, and it has to do with desync with the handling of the name of ES object cache entries. Basically, when the object is created and put into the cache, it uses the original encoding found in the document, but when it gets deleted, the name is always in Unicode, which is a problem because it means that entries created with non-Unicode encoding, like ANSI, never get removed from the cache, even after they're freed. So you can get this dangling pointers basically from the cache. They go into some detail on the structures involved that they reverse engineered and the exact paths for the UAF and where those string checks on the cache name happen. What's more interesting, though, is the exploitation portion. There they walk through how they got code execution bypassing ASLR, dep, and a control flow guard. How they do that is they do some heap grooming to get array buffer objects that are adjacent to each other in memory. They then create and free an ES object and overlap with strings to create a pointer to a fake array. They then get a handle to that fake array in JavaScript and use that to get an out-of-bounds write to smash the length of an adjacent array buffer with the heap grooming they set up earlier in order to get arbitrary read-write. It's kind of the standard thing you'll see with like browsers. It's kind of like that fake obj primitive that Salo popularized in the Attacking JavaScript Engines paper. So yeah, they get a code execution by overwriting a function pointer of the fake array. Now, one thing that's interesting is CFG is in play, which when I read that at first, I was like, okay, wouldn't CFG prevent this kind of thing though? But the way CFG works is it's basically there are certain areas where you are allowed to call into from a function pointer, and if you're not in that allow list, the access is blocked. But there are certain libraries that don't have CFG enabled, so that's basically how they got around it. They use rock gadgets from the library ICU CNB58, which I don't know exactly what that is, but it doesn't have CFG, so
that's all you need to know, really. It's no CFG. I was kind of disappointed because they talk about a successful exploit strategy needs to bypass CFG, and in fairness, a library that doesn't support control flow guard using that, that's a fair bypass. But when I read that, I was kind of hoping they'd have they'd end up talking about how they dealt with CFG rather than just we didn't need to because of this.
You were a bit disappointed.
It's fair, but I was definitely disappointed because I was hoping for another write-up kind of dealing with that. In fairness, with a lot of the CFG stuff, it's not a fine-grained CFG. It's basically you have to call real functions. So, there are viable gadgets. It's not like you can't do anything with it. I just like reading kind of how people are going about building up their gadgets with the whole functions, how they do their analysis and stuff. So I was looking forward to that in this one and didn't really get it. So yeah, a little bit disappointed. Ultimately, it's fair game, to go and use something that doesn't have, why would you do it the hard way?
Yeah, it's the end. I just saw your link in chat. Somehow that I didn't see that, but I'm just taking a quick look at it now, and we'll definitely do a shout out of it in this episode, which we'll get to in a little bit. So thanks for linking that, because yeah, somehow I missed that, but it looks like a very cool project. For now, though, we'll continue the exploitation stuff, and yeah, I will say though, summarizing this Exodus post, I liked this post. I liked how concise it was and to the point on the exploit stuff. I feel like they covered the sweet spot of background info without feeling like it was bombarding you with it. So yeah, I think they got that balance perfect of covering background info, but not too much. But yeah, the exploit strat was just stack pivoting using a gadget from that library, using a small ROP chain to write shellcode, and then using virtual protect to run that shellcode. So we'll get into our last exploit, which is a Linux kernel bug detailed by CDI and IOU ring, which is a newer subsystem introduced in 5.1 for doing performant IO by batching them together. The reason that it's more performant is because it basically allows you to use one syscall to do multiple IO operations instead of using multiple syscalls. And syscalls are pretty expensive in terms of performance. So
yeah, or even getting it without a syscall if you use the kernel polling, although that is not something that's exposed to unprivileged users.
Yeah. So one of the operations you can perform on IOU ring is the IO ring op close op, which queues a work request to close the attached file. Now they say the problem is in the close operation. As far as I can tell, and I believe as far as you can tell too, Z, when we were talking about this a little bit, the problem seems to be more in other paths that use that file, not in the close path.
Yeah,
because
so you can argue it both ways, and I kind of did this when we were talking about it, but so I guess before we dive into that, the issue itself, it doesn't increment the reference counter in a couple areas. When it grabs a reference. In a single-threaded run, this fd get will just grab the file, but won't actually increment the reference count, and the IO graph files, same thing, just grabs the reference. So then I would argue that the issue is with those not grabbing the ref count, or not incrementing the ref counter, rather than IO ring closing it because it thinks nobody has it. But I could understand the argument being that IO ring op close should be aware of those cases and account for them. I don't know. I mean, maybe the developers would agree with that. I feel like the blame is on not incrementing the reference counter, though. I feel like you should be doing that when you grab a reference. There shouldn't be these exceptions because, it's single threaded or whatever.
Yeah, it seems like a really weird like micro optimization or something. Like it's not like incrementing a ref count is particularly expensive. So I don't know why you would just be like, oh, it's single thread, screw it. Let's not grab a reference. Like I don't know, it's weird. But yeah, I mean the issue is that ref count kind of gets desynced. So because you're able to decrement it while it's still being in use, you can cause a UAF. And they detail some of the paths that can be taken to abuse that use after free. I feel like this write-up could have been done a little bit better. There was some areas where I had to personally go into the Linux kernel source and try to look at the relevant code to try to figure out the issue, because like they talk about the IO grab files path in the ZDI blog post, but they only mention it like once and in the snippet. Like they don't actually talk about how it's kind of intertwined with the other stuff they talk about. They do have a table at the end with the exploit timeline, but unless you're intimately familiar with the IOU ring subsystem and BPF, it doesn't really mean much to you. So yeah, I mean, I was a little bit disappointed with how it was written up, but the issue in itself is kind of just comes down to not managing that ref count properly. And yeah, I mean,
for their actual exploit here, it comes down, they get that ref count, so they end up talking about the exploitation, this map lookup element and map update element functions. Effectively, because of the because of that ref counter, it gets closed while it still has. Yeah, so yeah, I guess it is a dangling pointer. Basically, you end up controlling the values that go into a copy to user. So basically, you're able to tell it to read or write any kernel memory. I think it'll do a copy from user with one of these wrapped copy from user, I believe, and one of them. And then obviously there's a copy to user. So very powerful primitive of this when you've got the after it's been freed, and you've got control over the values.
So it uses. I'm just trying to double check something in their write-up. Sorry. So yeah, the arbitrary read and the arbitrary write are in two different paths, right? Just trying to verify that quickly.
Well, so
or they just talk about the arbitrary read.
No, now we're getting to looking. So the BPF copy key is a wrapper from the copy from user. So that's the one that I was...
Right. Okay. So I see. So when they add a key, they can get that path of getting the arbitrary read through the controlling the arguments copy to user. The other path is the update element, which has the arbitrary write primitive, which I believe is for like the message handling. So the reason I bring that up is for those not aware, like those APIs for copying data to and from userland are kind of smart. It's not like you can just pass a kernel pointer for like the destination and copy to user. It will verify that it's actually a userland address. So you couldn't abuse that for both an arbitrary read and an arbitrary write. You could only get an arb read there. So that's why that other path is needed for getting the arbitrary write. But yeah, once you have both, I mean, it's basically game over in kernel. All you have to do is smash the kernel task struct and you're done. So
yeah, unfortunately, like it seems kind of like an interesting vulnerability, but I don't feel like this write-off does it justice.
No. And IO Uring is kind of tough too because when like I was trying to look for the patch for this issue to try to better understand it, and unfortunately, like because the subsystem is so new, the movement that's happening in the code is huge.
Yeah,
so
very active.
Yeah, so it's hard to really even be able to diff and kind of figure it out that way because there's so much code changing. So yeah, I wish this exploit covered the issue a little bit better, but yeah, I mean, these ref count type issues are one of the most popular sources of kernel issues because it's the only thing it has to make sure that UAFs don't happen. So yeah, that sums up all the exploits. We do have one research post we wanted to cover this week, and it's the awesome Ned Williamson post on sockfuzzer from the P0 blog. In here, he talks about fuzzing setup he wrote and deployed called sockfuzzer, which targeted the XNU kernel networking stack. Kernel fuzzing is always an interesting topic because kernel presents some unique challenges when it comes to fuzzing, such as crashes being a lot more severe to deal with and a lot worse to recover from. Coverage is also harder to manage. You have like coverage flaking issues and whatnot. Introspection in general is just generally a lot harder to do. Plus, the state is very complex. You literally have all the processes and threads on the system sharing the same kernel state to some degree. Debugging kernel is also a total nightmare. I hate it. To the point where if I'm ever trying to like figure out a kernel issue, I will literally just modify the source of the kernel and rebuild it, which isn't always an option, especially if you're doing like Windows or whatever. But debugging kernel is just so painful that I don't even do it. I just don't bother. But yeah, like there's also a relative few amount of projects that are open source to target the kernel. You basically have syscaller and KFL. So there's not a lot of like public resources on the challenges that come with kernel fuzzing. One of the things that Ned talks about here is the different approaches when it comes to kernel that you can take. Doing some of the unit testing type work on code in the kernel directly, or doing like what syscaller does and doing the heavyweight syscall indication. And he mentioned some of the trade-offs involved with that, like with accuracy of reproducibility and the amount of overhead, the manual overhead that's involved on fuzzing. Because like what he does here is he pulls the kernel code into userland and fuzzes it there, which we've talked about that idea a little bit before. Maybe not specifically with kernel. I think we talked about it with trust zone applets, but it's the same kind of idea, right? You're pulling the code out of something that's expensive to get to in terms of performance, and you're just putting it in userland so it's faster, and you have more control over the code and you can more easily like rebuild it and whatnot.
Yeah, and I think we talked about is it micro fuzzing? Was that the paper?
I think so.
It was doing like specific Java functions, I think, and we were both saying like, we've seen this before, but this is the first time we're seeing a name go to it.
So microfuzzing is a bit tricky because I think we've seen it used in two different contexts. We've seen it used to fuzz patches, and we've seen it used in this context of like pulling things into user space and fuzzing it there. So it's a little bit weird because I think we've seen it used both ways, but I think you're right. I think microfuzzing was the term that was applied by one of the topics we've covered before. So yeah, like it's a cool idea and it does have some benefits. but there's always trade-offs and some of the other challenges that come with it, and that's kind of what Ned goes into detail here in this blog post on.
And
One of the things.
sorry to interrupt. I'll just add on that it was episode 29 where we talked about Hot Fuzz, which did DOS vulnerabilities through micro fuzzing. That was like, I think they're targeting for like well, anything that did resource consumption, but we ended up talking about that concept a fair bit during that episode.
Yeah, damn, that was a long time ago, 29. But yeah, he talks about some of the trade-offs, such as having to fake functionality to match the kernel API somewhat. He goes deep into that process of faking functionality, talking about how he used asserts to know when functionality was missing and had to be ported over. He also used asserts to block off privileged code paths, which I thought was cool. And the idea behind that being, if you like trigger an assert trigger crash, if you're using like code coverage guidance, then it's not going to get any coverage past that assert. So it's not going to spend time or a lot of time trying to hit that path. So yeah, I mean, there was like some really interesting tricks that he used in this blog post.
Yeah, I appreciated a lot of the overview. Like, in a sense, like using the asserts, all that, like, it seems obvious, especially if you've done it before, you've done something similar. Like, it seems obvious, like, okay, this is how you go and do it. But he's laying it all out there, especially for somebody who maybe hasn't gone into that. And I haven't done a lot of it either. I learned plenty here too. I'm not trying to come across as though I've done everything and all of that. But I thought this was a great, yeah, I thought this was a great write-up in that sense, just because he didn't make the assumption of course, I just did this and just brush it off. He covered what he did. And like, there's a lot of value in that information.
Yeah. Near the end, he also goes through one of the findings of the fuzzer, which was an IP6 mbuff double free, and how he went about triaging that and writing a reproducer going off of the information he had from the fuzzer he wrote. Overall, though, it's just a really solid post. I think this is probably my favorite post that we've covered in a while. Not only did it have like a lot of like interesting tricks, and like you said, like tricks that might be obvious to someone who does it a lot, but could be very useful for somebody trying to break in, but it was also like a really inspirational post, and it could give you some ideas if you're trying to fuzz a target, even if you're not trying to fuzz kernel or fuzz XNU. There's definitely stuff that can be taken away here and applied to other targets. So yeah, I mean, this was an awesome post. I loved it, to be honest. And yeah, it talks about a subject where there's just not a lot of new information beyond what I mentioned with syscaller and KFL. Also, worth shouting out, the project is open source. You can find it on GitHub near the end of the post. So if there's anything that you want to look at potentially taking out or just getting some clarification on by looking at the implementation, that is available to you. So yeah, that just makes it even more awesome. So we'll move into our shoutouts section of the show. First thing we have
first one, I'll actually inject the tool we just mentioned a couple topics ago, so we don't forget to bring it up. But fair. That is this tenant. I'm probably saying that incorrectly, but looks like it is a trace explorer for IDA. So we both just found out about this on episode, so I have not used it or had the time to really look into it. But it does, glancing at it while we've been talking, it does look interesting. If I were more of an IDA user, I would find it probably quite useful to be able to take the trace and see that within IDA.
That is a functionality I have wished for before, definitely. When I was doing like PS4 stuff, I was like, I wish I could just see like how this path is being taken, like, and
yeah, like where things came from, how it got there. I mean, it gives you that in a sense. It's kind of like time travel debugging. It looks like does it track registers too? Oh, I'm just looking at this one screenshot that looks like it's saying the registers. Well, I guess, yeah, I could do the assembly there to figure that out. So that seems quite useful. I wish it's on Binja. Might need to port it.
We got to shill some Binja. Yeah, I mean, especially if you're working with a target that doesn't have source code access. Although you can use this on black box targets, right? I just want to make sure. It's cross-platform. Yeah, as far as I can tell, all you need is the like binary and IDA. So
what's it using for the actual trace? Like, does it have what type format? Like, is this going to expect like the Intel PT or something?
As far as I can tell, I don't see anything suggesting that. So this looks like it could be useful for doing like black box targets.
Yeah, so it does mention here, how do I record an execution trace? This doesn't do that. You just need to provide it. It says you'll have to use dynamic binary instrumentation frameworks to generate a compatible execution trace.
Okay.
So they have a FAQ file here, they have a tracing README, sorry, which probably includes more information about the trace format. So you should be able to convert things into it. So yeah, that makes it more useful. I'm glad they don't like rely on you've got to do the Intel PT version or something, or relying on having that actively.
Yeah, tying it to a technology like a certain other project that we've mentioned, KFL. But yeah, I mean, this looks very cool, and like I said, it's something I've wished for before, and it provides a very useful level of introspection. So this is from the people over at the awesome people over at Red2 Systems. I think this is Marcus's repository, but yeah, I mean, this looks like a very awesome tool. So thank you for bringing it up. I'll definitely shout it out
Amy,
to a
I
few
think,
people
that
doing some
linked
research
it here. So
yeah. All right. So we also have some other shout outs. There was a new Zine that went out, temp.out. It'll be an interesting read.
I say
Zine. Okay. See, I think this is another one of those things where originally I used to call you Zai. So this is just another one of those areas where it's just that pronunciation carrying over. Yeah. So yeah, this will be an interesting read for some of you, I think. There was one article that I thought was funny in there, which was fuzzing Radare 2 for 0 days, which was a really, really dumb Python fuzzer that shook bugs out of Radare. I mean, it was so dumb that you could probably just have piped data from dev random into it and found the same issues. But yeah, I mean, there's some cool topics in here. There's also some other stuff that focuses more on like the area of malware, but it's always interesting to see new zines or zines or whatever that come up. So we wanted to give that a shout out.
Yeah, it looks like their focus is a little bit more on that malware dev or like the VX stuff. Or at least that's kind of what they mention. They kind of call back to the VX scene. So seems like that's what they're going for rather than like just exploitation. But obviously there's a ton of overlap, and odds are you'll find something interesting in it, even if you're maybe not quite into just the virus development.
Yeah, and Amy just mentioned in chat, like, she literally just catted dev urandom into R2 and found crashes. So, yeah, I mean, it doesn't look like particularly well-written code. And just, it's always fun to talk about people who still use, those people who are like, you're not a real hacker if you use IDA. Real hackers only use Radare.
Well, now there's like, is it Ryzen, R-I-Z-I-N, I think, or something? There's a new fork of R2.
Oh, yeah, I remember seeing something about that, but I didn't look into it too much.
Yeah, because I think Cutter officially supports that now instead of R2.
Does that make it less terrible?
Well, Cutter was at least kind of a decent-looking UI. I'll give it that much.
It looked nice, but it didn't work. So it was useless.
Yeah, I mean,
it was basically a trophy.
Yeah, I've joked about it before, but like my R2 experience was, I want to say like DEF CON quals in 14 or 15. It had R2, you could run a web UI on it. So I was playing one of the CTF challenges on my phone while I had to go out shopping and I was waiting in line for something. That's how I used R2. Was to kind of keep myself going like that. Beyond that, I haven't really used it.
Yeah, apparently that project was spawned over code of conduct stuff, according to Amy. So, and yeah, somebody mentioned Cutter 2.0. Smash 8 Tap mentioned Cutter 2.0 was released recently. Yeah, I mean, I don't know if I'll try Cutter again. I gave Cutter 2 chances already. And if I tried to load anything bigger than a pebble, it would just crash. And I was like, you know what? This is a waste of time. I'm not even bothering anymore. So maybe that situation's been somewhat remedied, especially if you don't use the R2 option. But like, yeah, I don't know if the crashing issues were specific to Cutter or if it was just R2 couldn't handle anything that was bigger than like 2 lines of code. So yeah, I don't know who exactly to pin the blame on there for the crashing issues, but it's just one of those things where I've given it a go. didn't leave a very good first impression. So it's just like, I'll just use Binja or whatever. Like, it's better. It has decompilation and stuff now. Like, I just, there's no reason for me to use anything else now at this point. So, yeah, so we'll move on to our next shout out, which is Teamstar and Seguza put out their Phoenix jailbreak kernel exploit for iOS 9.3.5. This was kind of a pretty old bug. I mean, 9.3.5 was years ago, obviously. But the exploit code is new. So, yeah, I just wanted to shout it out. I don't know specifics about the bug. They mentioned the bug was found by NSO Group and Ian Beer. It seems to be an IO-Kit issue, just at like a quick glance, which isn't surprising because at the time, like IO-Kit was kind of the bug farm of the day, I guess, or the bug farm of the year. I don't think it's really being looked at too much anymore because I think Apple's put a lot of effort into killing that attack surface off. But yeah, I mean, for anybody who's looking for like new exploit pocs to look through, this might be of interest to you, especially if you want, a bit of something that's a bit interesting in terms of history of what was used to jailbreak iOS in the past. But yeah, I mean, it won't be totally relevant to today's exploitation because iOS security is very fast moving. So there's been stuff added like why can't I think of the name of it? Pointer authentication, sorry, PAC, yeah. So like this exploit probably wouldn't be resilient to PAC. So yeah, I mean, there's a few things that wouldn't make this totally relevant for today, but it still might be interesting for people out there. Our final shout out is experiences with Apple Security Bounty from EvilBit. This is where EvilBit shares their experience with Apple's Security Bounty program. It's mostly a meta post. It doesn't really go into like technical details of a specific bug, but it more just gives some insights into Apple's program and some like critiques, but also some praises, like saying how their submission process is pretty smooth. But yeah, like I just think those insights might be interesting to some people out there. But yeah, I mean, not too much to cover technically, so we left it as a shout out. How can you compile and execute C code on iOS? Doesn't it have some serious overhead with sandboxing? I mean, yeah, I'm not totally sure with iOS. The common thing I know with iOS, if you're hitting it from the browser, is once you, because of WebSM and JIT or whatever, you can just like abuse JIT memory to just run assembly yourself. You don't even need to worry about C. So even if you can't run C code directly, you can just write C and compile it down into well, actually, since you can just run assembly in the JIT pages, you can just run the assembly directly there. I was thinking you could compile down into ROP chains, but you wouldn't even need to do that. So, yeah, I mean, maybe it's not super easy to run code on iOS compared to maybe like Android or whatever, but you can definitely do it, with enough effort. So,
well, I believe you can still call C from Objective-C, so you should be able to, or in theory, you could probably build an app too for some effect.
I think you can because some exploits have done that. They require you to self-sign the app.
Yeah, that's what I was going to get. Is like distributing that is going to be a bit more difficult, but at least for your own exploration, that would be an option. Yeah, I imagine like actually pulling it off, somebody were to go trying to compromise. It's just going to be compiled down to a payload that can be injected from like the userland exploit.
Yeah, I don't do iOS stuff, so I'm not sure what kind of restrictions they would have on like the C code that you can access from Objective-C. Because yeah, like the interop layer there is something that I'm not really familiar with, but yeah, like that's another option. It's just using your own app, kind of like what people do on Android for testing. Although Android is a little bit easier because you could just upload a compiled C binary over ADB and do it that way. Obviously with iOS, because Apple hates being able to do anything on their devices that they don't like, that's not so easy. But I imagine if you're doing that testing often, most people are just probably going to be using Corellium anyway. If that's kind of your main career focus is iOS, then you're probably going to have Corellium, which I imagine makes it a lot easier to do that kind of stuff anyway. So, yeah. That aside, that pretty much concludes all the topics we have for this week. Z, you don't have any like last minute thoughts or additions, do you?
Nope. We're good.
All right, cool. So thank you to everyone who tuned in. You can catch the VODs on Twitch or on YouTube, as well as Anchor. We're on pretty much all platforms that are common for podcasts. Follow us on Twitter and join our Discord for notifications and to join the community and see whenever we do other streams. We'll be back again next week at 3 p.m. Eastern, 12 p.m. Pacific. Once again, thanks to everyone who stopped by, and we will see you all then.